Good morning. Today we'll start up with the part that we have left in our last lecture. Now, today we'll start up with more on search strategies. The related terms in the search strategies are like condition action rules and the forward and backward chaining, right? So, they are basically rules and the chaining part that we'll be seeing now. Now, what is condition action rules? Now, condition action rules is one way of encoding knowledge. Now, condition action rules are nothing but how we encode the knowledge. Encoding the knowledge means you cannot directly say it as knowledge representation, but it is a way of how you can minimize the knowledge as well as you can infer certain further knowledge or data or assertions from them, right? Now, while encoding of the knowledge, the rules are written as you can see it here that there is an if condition. There is some condition that is there. If there is a condition, then the action for that condition. That means if then a condition, then there is an action for this condition that has been stated, right? Now we'll be seeing one or two examples for them. The first example, let's say we are going through the rule 1. Rule 1 talks about red light. So if the light is red, then stop. This is for the case of the traffic signals. Let's say we are having the traffic signal as green light, that is there in rule number 2. So if the light is green, then go. That means then you can move. Now I have made out a box here, right? There's a box out here. This box talks about that this whole part is the antecedent part, which you have gone through earlier. I have talked about this in our previous lectures. And this part, that means stop and go, comes under the category of consequent. So in the if else rule, that means in the condition action rules, if we are going through these examples, this part, these two parts are called as antecedent, and this part is called as a consequent. Now we had got now we have got what? Now more on the search strategies. Under these things we are having two related terms. The first one is the condition action rules and the second one is the forward and backward chaining. That means the chaining part. So let's talk about what is chaining now. Chaining is about sharing conditions between rules so that the same condition is evaluated once for all rules. Let us read it once more. That means it talks about the condition part, right? It talks about the condition part. That means out here, if the light is red, it is the condition, then the action is stop. Now sharing the conditions between the rules, that means I am having two rules, rule 1 and rule 2. Sharing the conditions between rules so that the same condition is evaluated once for all rules, right? So this process is called as chaining. Now the conditions are chained when they are shared between rules. This is a bit a smaller term that you can remember. That means conditions are basically what? Now when the conditions are chained when they are shared between various rules, and they should be shared at most once. Now what is chaining? What are the types of chaining? The types of the chaining are forward chaining as well as backward chaining. Forward chaining is also called as data driven. That means we move from the starting position towards the goal position, and this movement is generally guided by data. That's why you call the forward chaining as the data driven one. The backward chaining is called as the query driven. That means in this case there are certain conditional statements and its actions that we impose to move from the backward direction. That means from the goal towards the starting point or any other sub goals, right? We have discussed this thing in our last video lecture. Now I have added one more sentence out here. That means don't get confused with the forward and the backward searches that we have discussed earlier. This is forward and backward chaining. It is not the forward and the backward search, right? Now there is another another term that you must know, the activation of rules, right? Now the forward and backward chaining are the strategies for activation of the rules in the system. So if somebody is talking about activation function, that means talking about the activation of the rules or activation function, that this is nothing but the forward and the backward strategies itself that are implemented on the system. These activation rules in what does this activation does? Now this activation helps in drawing the inference. What do we mean by inference? Inference is something like, we have already talked about this earlier, still I'm just trying to remind you back. If there is one or two or three set of rules, from that if we can deduce further knowledge, that means we can infer something, this process is called as inferencing. So the activation of the rules helps in drawing the inferences. Let's talk about the inference rules now. Let's say I'm talking about the first inference rule. The first inference rule is what? Now the deductive inference rule. As we have already seen before, there are two classes of inference rules. The first one is the deductive inference rule and the second one is the abductive inference rule. Right? The first one is the deductive inference rule, you can see it here, and the second one is the abductive inference rule. Let's talk about the first one first. That means the deductive inference rule. In case of deductive inference rule, it is nothing but the forward chaining. What happens in forward chaining? Conclude from A to B and using A implies B, or you can read it as conclude from A, and if A implies B, then go to B. That means at the end. That means we are starting with the starting part, that means the initial part, and we go to the goal state. So we can write it somewhat like, it is a structure like we start from A mentioned here, and we are having certain rules here. By going through these rules, we reach for the goal state, that means the B. On the example, you can see it here, like it is raining. It is raining. Now in the second part, if it is raining, the street is wet. Hence, what I can infer from here is the street is wet. And what is this inference called? This inference is called as the deductive inference. This inference is called as the deductive inference. The deductive inference is about it is raining. That means I am talking about A. Now I am talking about A implies B or A deduces B. That means if it is raining, the street is wet. Hence we conclude that the street is wet. Now we'll be talking about the abductive inference rule. Abductive inference rule is nothing but the backward chaining. Now, in case of backward chaining, what happens? Now conclude from B to A where A implies B, right? So that means we are starting from the goal state and we are moving towards the initial state by certain implication of rules like A gives B or A implies B in fact. Now here it can be stated as just the reverse of the previous one. Initially we had A here and B here, and the implication, that means the rules were in between. Here B is at the top and A is below, and we are having A implies B in the middle in the same position itself. Now there's an example. The street is wet. It is raining. The street is wet. We are going in the backward direction, right? That means bottom up approach. The street is wet, so it is raining. The street is wet. Hence we can say that it is raining. That means we are moving from top to bottom, right? We are moving from top to bottom. Whereas in this case, we have moved from bottom to, here we are moving from bottom to top. Here we are moving from bottom to top. I'm sorry, here we are moving from bottom to top. In this case, we are moving from top to bottom, right? Chala. Now comes the forward chaining algorithm. I have simply written it as FCA because so that I don't have to write it again and again. Now FCA is what? Now, FCA is for drawing the inference from the rule base. FCA is for drawing the inference from the rule base. This part remains the same for FCA as well as for the backward chaining. In case of backward chaining also, backward chaining is the drawing of inference from the rule base. So their work is same, but the strategy is a bit different. Let us see what it is. In case of forward chaining algorithm is for drawing inference from the rule base. Now the forward chaining inference is data driven. As we already know, in case of forward chaining it is data driven, whereas in case of backward chaining it is query driven or towards the goal state. Now how does this algo works? Now it starts with a given situation. It starts with a given situation and moves towards the desired goal. That means it starts from the initial position and moves towards the desired goal by adding new assertions. What are these assertions called? These assertions are facts that are found. Then what it does, after we start moving from the initial position towards the goal state by adding new assertions or facts, while the new assertions are getting added, we compare the data of the working memory with the if condition and decide which rule to fire. Now, in case of forward chaining, what we are doing is there are certain stored information or stored data in the working memory, right? We are comparing this working memory data with the if condition data. What is this if condition data? If condition data is out here. We have discussed just a few minutes back. Now the if condition data is here. That means the working memory's data is compared with the if condition data. In case of backward chaining, what we'll be doing here is that we'll be talking about the conditions and not this, not the rules, right? Not the rules, this part, that means antecedent part. We'll be talking about the consequent part. So let us come down here and have a look, right? It compares the data in the working memory with the if condition and decides which rule to fire. Now let us see one of the examples. In the examples of data driven, that means forward chaining. In case of forward chaining, it moves from the data towards conclusion, right? It moves from data towards conclusion. It is just the reverse of the backward chaining. In case of backward chaining, we move from the conclusion towards the data. Why I'm comparing? Because this comparison makes you remember a lot of things, right? Now in case of data, what we are having is, let's say we are having a data a equal to 1, b equal to 2, and there are certain rules like if a equal to 1, b equal to 2, then c equal to 3, or there is another rule, if c equal to 3, then d equal to 4, and the conclusion is d equal to 4. Now these are arbitrary rules or facts or assertions. It doesn't have any relation whatsoever, right? We are just showing it via an example. Now so there is a data, there's a set of rules, and we are moving towards the conclusion. So this whole process of movement is from initial to the goal state. So the flow of process is somewhat like this, as it is shown by the arrow, right? We'll discuss one of the problems of forward chaining. Now given a rule base that contains the following rule set. What you're given with? A rule base that contains the following rule set. What are the rule sets? The rule set is rule 1, rule 2, rule 3, and rule 4. In rule 1, we do have if A and C, then F. That means if A and C is true, then F is true. This is rule number 1. Rule number 2 is if A and E is true, then it is G. Rule number 3 is if B is true, then it is E. Rule number 4 is if G is true, then it is D. What we have to prove here is if it is A and B, that means if A and B is true, then D is true, right? So we are having a set of rules, that means rule 1, rule 2, rule 3, and rule 4. Out of these, we have to prove if A and B is true, then D is true. Now what we have to do here is, first we'll be seeing whatever is there in your lecture slides that are already there with you. In that we do have a solution. I'll be discussing about that solution first, and after that there is another easier way that also I'll be talking about. Let's start up with the solution that has been provided. The solution talks about start with the given input A and B. That means initially you are having the data A and B, and it is true. Then start with the rule 1 and go forward down till a rule fire is found. Now this statement talks about start up with the input A and B. That means you are having the input A and B, and you have to go up to what? Now you have to go up to D. What is your work? Your work is to go from rule number 1, 2, 3 and 4. You have to gradually go from rule 1 to rule 4 and check for whether a new information is getting added or not. Now for that we'll be starting up our first iteration. That means the first movement from rule 1 towards rule 4. The first iteration, in the first iteration we stop at rule number 3. That means rule number 3 fires condition E is true and the new knowledge is found. Now why we are stopping at 3? Here you can see that we are starting with 1, we are not stopping up here. At 2 we are not stopping. At 3 we are stopping. That means if B is there, then it is E. I'll talk about this with my own explanation after a few moments. So in the first iteration we are stopping at 3. I'll not be saying you why we are stopping at 3 here because it is not there in the slides. I'll be talking about this. Rule 3 fires and condition E is true. That means now E is getting added into our new knowledge, right? Go further down and no further rule fires. End of the first iteration. That means in my first iteration what I'm doing is I am only picking up rule number 3. That means I am starting with my first iteration at rule 1, rule 2, rule 3, rule 4. But I am stopping at rule 3 and I am getting a new knowledge, that is E, right? Iteration 1 is complete. Now have we reached for the goal state? No. So go for the second iteration. In the second iteration what we are doing is we are again starting from the first. That means rule 1, rule 2, rule 3 and rule 4, right? In the second iteration where we are stopping is at rule 2 and we are getting a new knowledge again, that is G, right? Here you can see this. Rule 2 fires and G is true. That means we are adding up a new knowledge G. Then what is the next thing? Next rule that is getting fired? The next rule that is getting fired is G. G takes us to D. That is our condition to be proved, right? So that means rule 4 is the final rule. Rule 4 is fired and we are getting D and it is true and the goal is found. Hence it is proved. Now I'll be talking about an alternate, easier way. In this alternate way, what you got to do is you have to simply write down rule 1, rule 2, rule 3 and rule 4, right? I have just written it in a much more shorter fashion, right? Like I've written AC, it implies if AC is true, then F is true. If A is true, then G is true. If B is true, then E is true. If G is true, then T is true, right? Now what do you have to prove? The same thing. That means if A and B is true, then prove that D is true, right? What you got to do is make out a circle and write down the initial informations. What is the initial data? The given data or the added knowledge is in the circle. So firstly what you have done is you have written A and B. Why A and B? Because you are given with A and B and a set of rules that are there. That means rule 1, rule 2, rule 3 and rule 4. Fine. What you have to do is you will start up your iteration. Now how you are going to start up your iteration? For that I have put up an arrow here. You can see this arrow. That means you are moving from, that means you'll be moving from top to bottom. You'll be moving from top to bottom, right? So you are moving from rule 1 to rule 2 to rule 3 to rule 4, right? You are moving from rule 1 to rule 2 to rule 3 to rule 4. From top to bottom you are moving. And from which side? From the left hand side. What you have added up in your initial given data? Now in your initial given data you have got only A and B. Fine. I am starting up my first iteration. In my first iteration I am moving from rule 1 towards rule 4. While moving on from rule 1 towards rule 4, what is my new addition to this? My new addition is E, because I have added this due to rule number 3. And why I have stopped in rule number 3, now I'll be telling you. See, in my to prove section I have got A and B and I have to prove D, right? So somehow I'll be stopping at a position where either I'll be getting A or I'll be getting B or I'll be getting A and B together. If I'm getting A with something else and B with something else, then I'll not be stopping there. Hence A is here in rule number 1 with C, so I'll not be stopping here. A is here with E, so I'll not be stopping here. So I haven't got any exclusive A or exclusive AB there. So what I'll be doing is I'll be stopping on my third rule, that means B. out of A and B I have got B, and from B I have deduced one information via forward chaining, that is E. So after my first iteration I'll be writing E. And how I have got this E? From B I have got this E after my first iteration. After my second iteration, now am I getting anything else? Because I'll be checking only the left hand side. I have checked AC, I have checked AE, B and G. G is not there, so neither I have to prove G anywhere. What I have to do is I have to add up within this circle I have to come up from A and B to D. So what I have done is, after my first iteration, that means my movement from rule 1 to rule 4 is complete by stopping or using rule number 3. From rule number 3 I have deduced E, which I have written out here, right? The first iteration is complete and I have used rule number 3 out here. In the second iteration, what I am doing is I am starting again from the first, and from the first again, since within this circle I am having A, B and E, so I'll be checking for a combination of either A or B or something with B which is already there in my circle, or something with A which is already there in my circle. So I am already there, I am already having A with E in my circle. You can see it here. I am already having A and E within my first iteration circle. So what I'll be doing is I am having A and E, so I'll be stopping at rule number 2. So starting with rule number 1, I'll be stopping at rule number 2, right? In rule number 2, what I have deduced? Another new knowledge, that is G. What I'll be doing here is, after my second iteration, I'll be adding G here. I'll be moving even further below, right? Just a moment. I'll be moving further below. Since I have added up with G from here, so within my circle what I am having, A, B, E, G, and via using G, what that means I have started moving in my second iteration again from rule number 1. I don't need this rule number 1. In rule number 2, since I have added E from the first iteration, so I have added G in my second iteration from here. After my second iteration, rule number 3 has already been used. Now I'll be stopping at rule number 4, because since I have added G in my second iteration itself, now in the second iteration from G I'll be adding up D. So after the finishing of the second iteration, I'll be having A, B, E, G and D. Now in my second iteration, what are the things that I've added? The things that I've added is G and D out here by using rule number 2 and rule number 4. So now D is there in the circle. So I have started up with A and B and reached up to D. Hence I have proved. So to sum up all these things are not there in the slide, so you can just pay a certain amount of attention out here. So to sum up, we iterate the rules from the top to bottom from the left side, right? That means you'll be starting up from the rules left hand side, which I have shown via an arrow out here. Right? Start with the given data. Keep adding the new knowledge. This is what we have done. Now stop when one can include the RHS. What is this RHS out here? In this case, the RHS is nothing but the D. So you got to stop when you have included the RHS. That means to prove in the new knowledge. Now I have talked about catch. That means which rule to pick. Now which rule to pick? I have already said that you have to pick up that rule which is having exclusively from the inference part. That means from the starting goal part, what are the things are there? That means you have to catch up with something that is having A or B or A and B together. So that's why we have first taken up rule number B. From B we have generated E. Since we have got E, then with the combination of A and E we have generated G. By G we have generated D, and from here we have come to the conclusion part that we have proved it. So the catch is also over. In our next lecture we'll be starting up with the backward chaining. Thank you so very much.